Now person variable is dictionary. And what if I want to copy this dictionary to another variable, for example, another underscore person? Let's do that. Another person equal sign person. And now another person has same value as person. Now let's try to modify another person variable, and for instance, let's modify this name here. Another person, square brackets, name, and let's change name for instance to Bob, like that. Now name in another person variable was changed to Bob, but if I try to access person, I'll see that name was changed here to Bob as well. And the reason for that is that dictionary in Python is reference type. And now those variables another person and person hold actually pointers to the same place in memory, this place, where this dictionary is located. And when you modify, mutate, in other words, this dictionary, here we did that, you mutate it only in one place. And those pointers, another person and person, still point to the same place in memory. That's why here we see exactly the same dictionaries. That is called copy by reference. When you copy value of base type, for example string or boolean, you copy by value. Actual value is copied from one variable to another. With dictionaries, situation is opposite. We copy only pointer. That's very important to keep in mind. Same applies to lists. If you create list numbers, for instance, and its value will be list with numbers 1 and 2, and afterwards you copy numbers to another numbers, for instance, like that. And now let's add one more element to the numbers list using append method, and let's append number 3. I'll see that another numbers and numbers are the same. And the reason here is the same as for dictionaries. List is reference type in Python as well. And here on this line we copied only reference, not actual value. Value is the same for both variables, another numbers and numbers. Alright, that's what is called copy by reference, and please always be very careful when you copy values of such types as dictionary or list. Now let's have a look at one more container type in Python that is called set. Sets are created using curly braces, same as dictionaries. But they don't have keys and values as dictionaries do. Instead, set consists of elements, and each element must be immutable. It means that you are not able to insert to the set other dictionaries or lists. For instance, set could contain following elements: ABC, B, and 10. Now let's assign such value to the variable, for instance my underscore set, and now let's have a look at the type of the my set. And I see that my set is instance of the set class. Now let's have a look which methods are available here from my set variable. Let's press 2 tabs here, and I see many methods like copy, difference, discard, isSubset, pop, remove, and so on. Sets have even more methods than dictionaries in Python. But how sets actually differ from dictionaries? Let me demonstrate to you. Let's try to add one more element to my set that now has only 3 elements: A, B, C, 10, and B. Notice that order of those elements here in this output differs from the order how I actually entered elements when I created this my set variable. I entered A, B, C, B, and 10 first, but here in this output I see A, B, C, 10, and B. It means that order in sets does not matter, same as in dictionaries. But let's try to add one new element to this my set. For that there is method add, and let's add new element true. Let's access my set now. Now there are 4 elements. Let's add one more element, for instance number 20. Now there are 5 elements in the set. But if I try to add element that is already present in the set, for instance let's add number 10, I'll see that my set was not changed, and it still has only 5 elements. And that's what makes sets unique in Python. Set holds only unique values, and it doesn't add duplicates. And in some cases such feature of sets might be very useful. Sets don't store duplicates. You could of course remove specific element from the set using method remove, and let's remove element 20, and element 20 was successfully removed from the set.